Today we're going to talk about redox under alkaline conditions. And alkaline is just another word that means basic. So what we're going to do is look at number 11 on page 153. You should have already checked your answer when we went over homework. However, I told you when you did this one to ignore the directions, and so now we're going to resolve the same problem, but now we're going to do it under basic conditions. It's pretty easy because it really follows what you've already done. So let's look at your two half reactions. So these are the two half reactions that you should have gotten when you did last night's homework, and I know that you have an overall redox reaction written underneath as well. But what we need to do is look at each individual half reaction. And when you're looking at these reactions, what you need to think about is, if I tell you this is under basic conditions, what is something that doesn't belong in the balanced equation? So another way to say that is, if this is happening under acidic conditions, so what piece of this equation shows you that it's acidic? So what you should notice is that we have H pluses, and you should know that H pluses mean acidic. So those can't exist when we're doing it under basic conditions. So here's how we fix it. What we do is think about what is available in a basic solution. It's not H pluses, so you should be thinking, oh, OHs. So what we're going to do is we're going to add OHs. However many H's you had, we're going to add OHs to that side, and we're going to add them to this side as well. So in the reduction half reaction, how many hydroxides should I be adding? Should have told me 4. And if I add them to this side, I have to add them to this side. It's kind of like in math when you're solving for something and you have to do, if you do something to one side of the equation, you have to do it to the other side. But what is special here is that you have to look at this. And when you have H plus and OH minus, what can those two things come together to make? Hopefully you just said water, because that's what it does. These two pieces here come together and form water. So in this case, I would have 4 waters. When you're looking at the rest of the equation, everything else is the same. So the way that this is gonna look is like this. So the oxidation half reaction actually is this reaction right here. Now let's do that for the reduction half reaction. And when you do this for the reduction half reaction, what you should see though is that you end up having waters on both sides. So remember, when things show up on both sides, they cancel each other out. So we're going to simplify this just a little bit more. And so you get this to be your reduction half reaction. And then you would add them together to find the overall reaction. So you'd have to multiply the oxidation half reaction by 3 and the reduction half reaction by 2. And when I was re-looking at our equations, I missed that there is the same thing on each side. So you would have to rewrite this one also. So there would be no waters on this side, and there would be 1 water on this side for that half reaction. And I know you're not going to be lazy like me and you're going to actually have rewritten it or used your eraser and erase it. But when you see things that are the same on both sides, make sure that you're canceling them out. Okay, so now you want to add those two equations together and get your final overall reaction. So after you multiply all your coefficients and add everything together, you get something that looks like this. But remember, you got to go back through and cancel things that are the same on both sides. And so this is what you get when you add them together and cancel things that are the same. Remember, 2 ways to double check. Are my atoms all balanced? And then are my charges all balanced? And in this case, they both are, so we're good to go. All right, so let's look at this next one, which is number 12 on page 153. Again, you've already solved it, but you did it under acidic conditions. So why don't you go ahead and try to solve it. It's going to solve exactly the same way as number 11, and you should have notes on how to do that. And when you think you're finished, keep going with the screencast, and you'll be able to see the answer. So here are the two half reactions that you would have written. And then remember, what you have to do is say we're in basic conditions. So I can't have any H pluses. So in order to cancel out my H pluses, I'm going to add OHs to it. So I'm going to add 12 OHs on this side, and if I do it on that side, I have to do it on this side as well. So here I'm going to add 5 OHs. If I do it on this side, I have to do it on the, ooh, my slide just moved. If I add 5 OHs on that side, then I have to add 5 OHs on this side as well. And then remember, when you have the H's and the OHs together, this forms waters. So I'm going to have 12 waters. This forms waters. So I'm going to have 5 waters. And then now, this doesn't exist anymore. This doesn't exist anymore because they came together to have this. But then if you look at what's left, there are no H pluses. And there are only OH minuses floating around. And that is valid when it's basic. So then now we just need to combine these equations together. So this is what you get when you cancel out stuff that's the same on both sides. And then what you should recognize is that you're going to have to multiply this entire equation by 2 so that the number of electrons matches up, and then you just need to combine the two equations. And so this should be the final answer that you get. Remember, 2 ways to double check. The total charge, if you were adding up all the oxidation numbers, this side is a -6, this side is a -4 plus a -2, so this side is -6 also. So check that. And if you count atoms, they are all balanced as well. So this is your overall redox equation under basic conditions for this reaction. So the only difference when you're doing these is you solve them at the beginning just like they were acidic. And then you're going to do this step where you, this step where you add the OHs to the equation, but you always have to remember you're adding them to both sides of the equation. So if you add 5 on the product side, you have to add 5 on the reactant side as well to keep it balanced still. Remember, the reason why you're adding OHs is because it's basic, and you know that if something's basic, it has an OH concentration. It should not have H pluses floating around because that would make it an acid. So other than that, these are just like what we have been doing. Hope the screencast helped you. We will, you'll have a couple more problems to do with this form next week. Basic conditions is not on Monday's quiz. All right, go start your homework. You need to go to the website to find out what your homework is. Have a great weekend, guys.